Hello, good day. Today I'm going to be showcasing my visual data representations for quantum computing for Emerging Tech Assessment 2. To begin with, here we have a chorophyllt map which showcases a world map with the data represented. This one is for the adoption of quantum computing by country. Here, this map highlights how different countries are investing in adopting quantum computing. The shading levels represent the relative level of activity in areas such as their research output, government funding, and corporate involvement and technology development. USA, China, and Germany are some of the countries currently leading the field, but you can also see the lesser fields of India, Spain, and Italy there too. As for now, the next chart we have is a network graph. The network graph is about the entanglement and superpositions of quantum systems. The network graph shows relationship between these individual qubits and quantum states and their entanglement systems. The lines represent sort of connections formed through entanglement or their superposition. It demonstrates how certain qubits are entangled into the belt state or exist within these superpositions, revealing their core building blocks of quantum computing. Here we have a radar chart. The radar chart represents the comparative properties of the quantum states. The chart compares several quantum states such as the probes, the Bell state, the superpositions, and the positives and negatives. It evaluates each state based on its probability of measuring certain outcomes, level of their superpositions, entanglement, and the uncertainty measurement. This helps to visualize how quantum states differ in their behavior and complexity. Here's a Sankey diagram which shows the flow of quantum gates in a circuit. The diagram shows how quantum gates operate within these circuits. It starts with a qubit in their initial state and tracks their flow through each of the various quantum logic gates, such as the Hardman, the C0 gate, and the Z gate. The showcases for before it reaches its output state that you can see at the end here. This graph visually explains how quantum algorithms manipulate qubits to perform complex computations that like a mere laptop or human can't. And finally, we have a bar chart that shows the error rate of quantum hardware platforms. The chart compares various quantum computing platforms based on their average error rates, qubit count, and such forth. The lower the error rates indicate better hardware fidelity in them. The chart includes superconducting platforms like IBM or Google, and also trapped ion platforms like IonQ and Honeywell. It helps to illustrate which technologies are more mature and precise than others are. This has been it for my visual data representation for quantum computing and emerging tech assessment 2. Thank you for watching.